Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, so in this video we're looking at paper 1 from the Edexcel November 2018 specification. This is the second video in the playlist. In the first video we completed through to question number 7. We're going to start here from question number 8. Please do stop the video, have a go at each of the questions and then compare your solutions. Okay, so from question 8 onwards, we've got write down the exact value of tan 45 degrees. Now, I appreciate people will know this or they might have some way of doing it. What I want to do is just spend a couple of minutes going through how I would do this. And I appreciate it's a lot of work for 1 mark, but it might be useful and help in the future. And I just thought it was quite a useful way to remember some of these trigonometric ratios, where what we do is we say, well, we've got 0, 30, 45, 60 and 90. Okay, and what I'm going to do is then with those I'm going to write sine, cos and tan. Okay, hopefully you can see that up on the board or up on the video. Okay, so the first thing is I need to write in all of the values, and it's relatively straightforward. If you write it in this format, it's okay, because we write root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, okay? And then we go back the other way. So it's going to be root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, and root 0 over 2. And I appreciate they don't really make too much sense, but hopefully that'll be okay for you. All right, so the next little bit is what we do is we kind of look then at the numbers that are left, okay, if we take away the denominators of 2. Okay, so the first one is actually going to be 0, okay, then the second one is going to be root 1 over root 3, root 2 over root 2, root 3 over root 1, and root 4 over root 0, which is actually indeterminate, so it doesn't actually, because you can't divide by 0, so it's not applicable. So tan is probably the only one that you need to just be a little bit careful of. But what it does is it allows you then to define all of these trigonometric ratios that you might be asked to quote. Okay, so in this particular case now I've got to being asked for the tan of 45 degrees. So the tan of 45 degrees is root 2 over root 2. Well, root 2 divided by root 2 is going to be 1. So hopefully that's okay for you. It just might be an easy way of remembering these things. Please do put a comment in if you're not sure about any of those, and I might do a separate video on it sometime. Okay, so let's have a look at that. Tan of 45 degrees is 1. Okay, then it says here is a right angled triangle. The cos of 60 degrees equals 0.5. Work out the value of x. Okay, no problem. So it is actually a SohCahToa type question. Okay, so I'm going to write SohCahToa. And the next thing I would do is I would label the lines, the sides of the triangle itself. So this is opposite. Okay, this is the adjacent. And then this is the hypotenuse. So in this particular case, if I want to find out x, well, I've got the adjacent and I've got the value of 60 degrees, and I've actually been told the cosine is actually 0.5. So I should be able to put all of this together. So we're saying that the cosine is the adjacent over the hypotenuse. Okay, so let's put in some numbers here. So I've got the cos of 60 equals the adjacent, which is 4, divided by the hypotenuse, which I don't know. Okay, so it's a case then of kind of manipulating this and figuring out the value of x. Okay, well, let's go from there. So cos of 60 degrees is going to be 0.5 because we're told that. The adjacent is 4. The hypotenuse is this one here, which is x. Okay, so I need to find a way of getting hypotenuse to being the subject of this particular formula. So if I multiply both sides by hip, I get to lose that, and I get 0.5 times the hypotenuse equals 4. Divide through by 0.5, so the hypotenuse equals 4 over 0.5, which equals 8. So it's actually 8 centimeters as an answer. Now, I appreciate this might be a little bit tricky, but basically when you've got the hypotenuse as the denominator, you need to multiply through by the hypotenuse in order to lose that denominator. Then I get hypotenuse times 0.5, which is this. That equals 4. And then effectively what I've done then is divided through by 0.5. And that gives me 4 divided by 0.5, which equals 8. Okay, so algebra does appear in all of these things, so it's well worthwhile getting to grips with how you would do these algebra type equations. Rather than writing hypotenuse, you could write x and it looks exactly like an algebra equation. Okay, so let's have a look at the next one then. So we've got a cumulative frequency diagram. Now this is going to be a little bit tricky on the video, but I'll do my best to kind of draw this out in a way that kind of makes sense. So it says the times of the 48 trains left the station on Monday were recorded. The cumulative frequency gives information about the number of minutes trains were delayed correct in the nearest minute. Okay, that's great. So then it says the shortest delay was 0. This is right at the bottom here. Shortest delay was 0, longest delay was 42. Okay, that's fine. So what we're going to do then is on the grid draw a box plot for the information about the delays on Monday, which is the part A here. Okay, now probably the easiest way is actually to really refer back to the graph itself. So the first thing is, I know there's 48 trains, so therefore the 24th train, which is going to be this one over here, is going to be the median value. So this is, if you like, 10, okay, the median value. Which means that the 12th train is going to be the lower quartile, which is this value here. And that's the lower quartile, okay? The upper quartile is going to be the 36th train, okay? So that's going to be this one up here. Bring it down, all the way down to the bottom here. I appreciate I'm doing this without a ruler. Okay, but what we've got here then is actually the box plot that they want us to put onto question A, onto there. So I've drawn it directly from the diagram, and then you just need to transpose it a little bit. Now, the only issue you've got is it says the longest delay was 42 minutes. Okay, well, that means the box plot is going to finish at this point 42 minutes. So that's the only thing to be aware of by doing this. But certainly to get an idea of what the box plot would look like, that would work very well for you. So let's just transpose that actually onto the grid itself. So I'm going to have 0. I'm going to have, this is going to be, I think it comes out at going to be 4 minutes is this one here. Okay, then I've got 10 minutes is this one here. Okay, apologies for doing this without a ruler. Okay, and also my lines are a bit wobbly. Okay, all the way up to 42 minutes, which is going to be there. Okay, and that with the box plot for the delay. Okay, on Monday. Then it says at the bottom there, 48 trains left the station on Tuesday. Box plot gives information about the delays on Tuesday. Okay, that's fine, no problem. Okay, happy with that. And then it says in part B, which goes on to the next part. Now, this is going to be a little bit tricky, but I'll try to sort of hold the two together there. Okay, so it says, compare the distribution in delays on Monday with the distribution of the delays on Tuesday. Well, okay, I don't know really. What you could say is the interquartile range on Tuesday was smaller than the interquartile range on the Monday. So IQ on Tuesday was going to be the difference between 17 and what's that, 6, so that's going to be 11, and on Monday it's going to be the difference between 20 and 4, which is going to be 16. Okay, you could also say the median delay on Monday was 10 and the median delay on Tuesday was 9. So I'll just write that in, okay, and hopefully you'll be able to read my very quick handwriting, or at least these notes. So the median on, I think we said on the Monday is 10, and on Tuesday is gonna be, I think less than that, wasn't it? That's going to be 9 minutes. Okay, that's fine, so that'll give you 1 mark. Okay, second one will be the IQ range on Tuesday. IQ on Tuesday is going to be less, I think. Yeah, it's less because it's going to be the difference between 17 and 6, which is equal to 11, and on IQ on Monday would be the difference between 20 and 4, which equals 16. Okay, I'm sure you'll do a better job than me of putting that in some sort of cohesive sort of couple of sentences, but, you know, hopefully that's all right for you. Okay, then it says, Mary says, the longest delay on Tuesday was 33. This means there must be some delays between 25 and 30. Well, is she right? Well, we don't know. We don't know if there were delays between these times. What we do know is that there were definitely delays between 17 and 33 minutes. Okay, that's all we know. We don't know where those particular times were. Okay, so the way I would write this out is something on the region of it's unknown. And then I would put something like, we don't know if there were delays. We don't know if there were delays between 25 and 30 minutes, 25 and 30 minutes, only that there are between 17 and 33 minutes. Okay, so I appreciate that's probably not a great answer, but it certainly would get you 1 mark, so I've probably not explained it particularly well. But if you go back to looking at cumulative frequency information and box plots are a representation of a range, not actual specific data or specific detail. Okay, so we're into 13 minutes. We're going to carry on just a little bit further. So let's have a look at number 10. Okay, number 10, we're going to simplify this particular expression. So we've got x minus 1 squared at the bottom. So it means that at the top we've got x minus 1. And at the bottom I'm going to have 5 times x minus 1 multiplied by x minus 1. Well, that's okay. We can just cancel those out. Okay, remember that's going to be, if you like, 1 lot of x minus 1. So it's going to be 1 over 5 times x minus 1. Okay, hopefully that's all right for you, fairly straightforward. Then it says factorise fully 50 minus 2y squared. Okay, so fully, all right, now that's why it's 2 marks. If we just do 1 mark by saying, well, okay, that's going to be 2 times 25 minus y squared, that would get you 1 mark. However, what they're after is factorising this as the difference of 2 squares. Remember that 25 is a square number, and the number in front of the y here is going to be 1, which is also a square number. So we could write that as 2 times 5 plus y multiplied by 5 minus y. And that's what they mean by factorise fully for those sorts of questions. Okay, let's move on then to question number 11, which is all about breakfast cereal. Again, it's a little bit of a long kind of wordy question. You just got to sort of work your way through it if you can. Okay, so please do stop the video, have a look at this. So it then says, Jack and Sadia went to work for a company that sells boxes of breakfast cereal. Company wants to have a special offer. Here's Jack's idea. Here is Sadia's idea. Okay, so Jack says put 25% more cereal into each box and do not change the price. Fine. Okay, so in other words, what Jack is saying is that let's say the cereal is £1. Okay, well, we're going to get 125% for £1. Okay. That makes sense, doesn't it? Hopefully. So let's just kind of work through that a little bit, because it's 125% for £1. And we've got to compare that with reduce the price and do not change the amount of cereal in the box. In other words, the cereal for Sadia's idea is going to be 100%, whereas for Jack's idea, it's going to be 125%. So what we've got to do is find the value of 100% in Jack's idea. Okay, so we've got 125% for 100 pence, if you like. Okay, so what I need to do then is work out what the value would be for 100%. So I'm going to divide through by 5. That'll give me 25%. Okay, and that's going to equal, sorry, this is 4, not of. 4 divide through by 5 is going to be 20p. Okay, so they get 25% cereal for 20p, which would mean they get 100% for 80p. Okay, so in other words, Sadia's idea, in order for her to give the same value of money as Jack's idea, Sadia would need to reduce hers from £1 down to 80p, which is a price reduction of 20%. Okay, so Sadia would need to reduce by 20%. Okay, and that would give you the same value. Okay, hopefully that's okay for you. I think in the interest of time, we've got about 3 or 4 minutes, so I'm actually going to go on to question number 12. Now, question number 12 is one of those proof questions, so we'll kind of leave it once we've finished at the end of question 12. Okay, and that should give us roughly about 20 minutes for this particular video. Okay, question number 12. Not everybody likes dealing with these sorts of questions. I must admit, I'm not fantastically partial myself, but it kind of is part of the curriculum, so we need to have a go at them. Okay, so what have we got? Well, it's a bit of one that I'm going to have to move around a little bit on the screen. But what we're being asked to do is work out the size of angle CAO, which is actually going to be this one here. Okay. Right, so we've got a little bit of work to do on that. And also the worst thing is that we've got to actually give reasons and show our working as we go through this sort of thing. Okay, so the first thing I'm going to do is I'm going to say that I'm going to try not to move this around too much, and I'm going to try and write either side of the circle, because otherwise I'm going to be moving this up and down. Okay, so the first thing I'm going to do is I'm going to say, well, actually, angle BCA equals 56 degrees, and that's because of the alternate segment. Okay, so you do need to know your circle theorems. That means this must be 56 degrees. Okay, right, hopefully that's all right for you. So it's an alternate segment to this one is this one. Okay, the next thing I need to put in is that angle BOA is going to be equal to double that. It's going to be 112 degrees. And the reason that is because angles at the center are double angles at circumference. Okay, hopefully you can read my writing. I'm just trying to do this in the interest of time. It's a little bit tricky, but basically what we're saying then is that this must be 112 degrees. Okay, all right, well, the next thing is that I need to recognize that this BOA is an isosceles triangle. Now, the reason I know that is because OA and OB must be the same as each other because both of them are radius. So I can actually say that triangle BOA is isosceles. Okay, now that allows me then to work out this angle here. Okay, and this angle here, because they're both going to be the same because it's an isosceles triangle. So angle OAB, which is this angle here, OAB, is going to be 180 degrees minus 112, all divided by 2, which means that angle OAB is going to be 34 degrees, which is this bit here, 34 degrees. Okay, right, so we're getting a little bit closer with this now. Okay, now the next thing is that we know that that must be 34 degrees. We also know that a tangent meets a radius at 90 degrees. Okay, so where are we? DAO, it means this plus this would be 90 degrees. And indeed that's true because 56 plus 34 is equal to 90 degrees. Okay, so let's have a look then at the next little bit of this. Well, what it means then is that if we know that this angle is 35 and this angle is 34, we also know then that this angle together is going to be 69 degrees, okay? So what we need to do is try and figure out how we can work out this angle in here, okay? Well, we've got a triangle, haven't we? Okay, now it's a little bit tricky to see and hopefully you can see it on the actual screen, but our triangle then is going to be triangle BCA. So it's this big triangle here, okay? Now, what I've got then is going to be working out this angle here. So this angle here is angle, that equals 180 degrees, okay? So this angle, CAB, is going to be equal to 180 degrees minus this 56 minus this, which is 69. So that's going to give us 55 degrees. Now 55 degrees, it's so difficult to do this actually on the video, but this 55 degrees, if I kind of draw this in, this is going to be angle A, which is this one here. Okay, so I'll draw that in. And what we've just figured out is that must be 55 degrees, because we've also figured out that this is 56 and this one at the top is going to be 69 degrees. So it's a bit of an awkward triangle. But what we need to do then is use this value of A, knowing that we've already got, so here's A, and we've already got this at 34 degrees. Okay, hopefully you can see that on the screen. And because we've already got that at 34 degrees, which is this OAB, then if I want to work out CAO, which is the one that I'm after, then it's going to be 55 take away 34 degrees, and 55 take away 34 degrees is 21 degrees. That will answer this particular question. Oh my goodness, okay. So it's taken a little bit of time to figure out that this would be 21 degrees. Okay, so if I just write in here, have I got a bit of space for this? I'm going to write in here that angle CAO equals 55 degrees minus 34 degrees, which equals 21 degrees. And just for the purposes of kind of clarity, what I'll do is I put on here that this 55 degrees is going to be angle CAB, and this 34 degrees is going to be angle OAB. Okay, it's one of those questions I think where you need to print off the actual paper itself, work your way through it and see if you can figure out. Usually they're all right. Once you get used to the alternate segment theorem and also the angle at the center is double the angle at circumference, it's usually not too bad, but I think for the purposes of a video it's quite difficult to make that transition. However, it's a really good point to stop the video. Okay, so we'll stop the video at this particular question. This is the second video in this playlist where we're looking at this paper. From the next video we're going to start from question 13 onwards. I don't think it gets too much trickier, but we'll see how we get on with it, and I'll look forward to seeing you inside the next video.